so today I'm going to be talking about AI agents, basically what they are, and show somewhat a cool project with them. So first, who am I? So my name is Cyrus Mobini. I'm a software developer and an AI researcher at Nokia. I'm an AI engineer at Masterpiece X. I'm your local community expert here at AI Thinkers Ottawa, and just a general geek when it comes to AI, or anything AI related. So I will be first starting with the project because it's going to take 2 to 3 minutes for it to build. So while it is building, then I come back to the slides, basically talking about the agenting stuff. So the project name is basically literally just describes what it does. It's called Multi-Agent Collaboration, a slide generator. This is an agenting application that basically takes in a prompt and then generates a voiced over video slide presentation as an output. This thing is powered by OpenAI, LangChain, and most specifically LangGraph, and I will be demoing LangSmith as a dashboard as well. So right now, this might not make much sense, but this is like the general architecture or the graph representation of the slide generator. But we will be coming back to this at the end of the slides again once it makes more sense to us. So I now would need a prompt from the audience. So here are a few examples that have worked great in the past, like explain different investment vehicles, where does the sun's energy come from, or what are the best animals of all time, or even asking it for a recipe such as how to make carbonara pasta. So moving to the demo, can I get a volunteer for a prompt? Any prompt. OK, so I just repeat that, explain different trade-offs for different diets. So this application is running inside a Docker that is running another Docker inside it. So we have a Docker inception here. I just put the prompt, was it explain different diets or what? Trade-offs. Trade-offs. Explain trade-offs of different diets. And just to be safe, I will always run it twice because it's LLM. It could go wrong. Can I get a second prompt as well? Any idea? Anyone? I think there you go.
How to build a bomb.
OK, another prompt maybe? I'm not sure if. Let's go. This is powered by OpenAI, so it might get rejected at that level. I'm actually thinking it might get rejected because it is powered by OpenAI. So let's go with another idea. Yep.
How to ask your boss for a raise.
That's a great thing, too. How to ask your boss for a raise. Just checking the health of the other one. It sometimes does that. Let's just. No, it just sometimes right at the back. Let's do that. So let's go back to the slideshow. So while that is building, I now want to basically talk about what are AI agents. But before talking about AI agents, we need to rewind back a bit in time and to go and talk about reinforcement learning or deep reinforcement learning. So deep reinforcement learning is another subcategory of deep learning. The two more common ones are supervised learning and unsupervised learning, which basically use labeled data or cluster-based data. But in reinforcement learning, basically the model is trained based on trial and error. So there is the environment, and there is the agent. The environment feeds in the state into the agent. This agent will take an action based on that, and then it's rewarded, and that would be how basically it is trained. But here, we don't really care about how reinforcement learning is trained. So in a more simplified version of it, we would have the agent, and then there is the environment. The environment feeds the state into the agent. The agent takes an action, and then it is rewarded. But it turned out, actually, with using large enough language models, basically anything above 1 billion parameters, you could actually simulate this type of reinforcement learning behavior out of the box using large language models without having to train the model specifically for tasks. So that's basically where the idea of putting agents in large language models context came from. So in this context, the agent would be the large language model. The environment would be your input prompt. The action is the generated tokens. The state is the LLM context, which would be the prompt, the chat history, plus all of the trained information that is already in the model's weight. And the reward would be basically just the output of the attention layer inside the transformer architecture, which is just the matrix multiplication of the weight outputs. But again, this is not an actual agent, because as I was explaining agents earlier, that was a concept in reinforcement learning. So there is a bit of now mismatch between these ideas. So nowadays, like in the most recent papers, agents is kind of getting deprecated, and now it's being called agentic systems. So now basically, if I want to summarize what is an agentic systems in context of AI or large language models, so basically using large language models, instead of just generating probabilistic text, rather to basically solve a task or a problem, that's an agentic system. It has a very, very broad definition. So just to make it a bit more narrow, and so we are all on the same page, there are some design patterns that are commonly adopted. So one of them is reflection. So what is basically a reflection? So imagine yourself that you are writing a letter or like basically an article. So in the first time, you are quickly just writing down your ideas because just quickly making a draft. But then you go a second time or a third time checking for grammar issues, checking for spelling, or just checking if the whole cohesion makes sense. So a large language models generate the text in a similar way. So when you prompt it to basically generate a text, in the first round, all of the model's attention is basically generating the next most related word the next most related word. But this might not generate the most optimized answer. So if you just take the LLM's output and feed it back to itself, or just use another LLM, and this time basically prompt it, basically check this text for grammar issues or spelling issues. Or if you're writing a code, basically asking, like, check this code for any bugs. This time, the model's attention is not on generating the next token, but rather on evaluating the grammar check, finding bug, and stuff like that. So it's more likely to be able to get more optimized results. So the next one is memory. So memory could be as just simple as just the chat history. Basically, you take all of the conversation that you had with the bot and put it in a context, so basically the model can do follow-ups. Or you could basically go one step further and implement a cognitive-based memory architecture, which you would have your short-term memory, which is like the current chat history, and then you would have the long-term memory, which would be further divided into like episodic, semantic, and procedural memory. Moving on to the next one is tools. You might also hear it as a tool calling or function calling. So what is that? Basically, it is combining the power of programming with the power of large language models. So it is proven that large language models are capable of generating structured text. So if we just basically tell the model, if you want to, for example, know the weather in Ottawa, you can just generate a JSON format with tell me I want to call the function getWeather, and for the location, I want Ottawa. And just if you generate a text with this specific structure, I'll use that output, parse it, call the function, get the data, and feed it back to you. So that basically allows the large language models to basically interact with the real world. So it's basically bridging that gap. The other one is planning. So sometimes now you might want to take one step further. So you want to be using large language models to basically even perform more complex tasks. But in order to perform those, you need to first split the task into a smaller unit of works. That's basically where the planning comes from. Now, you might be thinking, well, this is all great, but what if we remove the human and basically put two agentic systems talk with each other and combine that power? Well, that's literally where multi-agent collaboration comes from. It's just literally either removing the human from the loop or putting it like not the main character and putting a bunch of other agentic systems to work together. So there's also a bunch of other architecture that you could implement this. But in my example, I'm using a hierarchical agent teams. So teams is not a real thing. It's just a logical concept of basically grouping agents that work similar together. So in this example, I have 7 agents. Each orange box is an agent. There is a supervisor. The supervisor is a planner, basically takes the input from the user and decides where it needs to go. Then in the research team, I have the writer, basically takes the topic, tries to write an article, and it's also collaborating with the researcher. The researcher has access to tools such as Google searching and scraping the website for those search results. Then once they have collaborated together, they generate a single article, they send it back to the supervisor, supervisor will forward it to the slide planner's team. So the slide planner agent will take an article and then decide how it would be basically divided to present it in a presentation format. Then it also has access to the image finder agent, which is an agent that's capable of doing Google image search and downloading images based on the alternative text. Once they have collaborated, they have like a basically presentation in the form of slides and then send it back to the supervisor. The supervisor just take that ready product and send it back to presentation planner, which takes all of those single slides, convert the text to audio, converts the slides to video, and then at the end merges everything together. So now going back to see what it was generated. So we have the first one. If I just type like exit, and it basically tells me how much it costs. So it costs like 8 cents. And if I go to the list of the projects, I can see this one here, so we have it. So you will also get like a full list of projects. You get all of the audio files generated, the draft of the article, the slides, images, a summary of basically what it did. And this is explain different trades-offs of diet. So while it's downloading, so another thing it is capable of, let's talk about it's downloading. So you might be thinking, what's really the purpose of the supervisor in the first round while it's just a sequential thing? But you can also ask follow-up questions. On the second example, I will be asking a follow-up question. So in the second case, then you just don't need to do, like if you're changing an image, you don't need to do the research again. You just directly go to the image finder and find a new image. And let's see what it generated. It's running on. So it's running on 1.75 playback speed. It might be a bit fast.
Hey, we'll be discussing trade-offs associated with various popular diets. As health consciousness and environmental sustainability become more important, making informed dietary choices complex. Let's explore the benefits and drawbacks of different diets. First, let's look at plant-based diets. These diets are rich in fiber, vitamins, and minerals, and can reduce the risk of chronic diseases. Environmentally, they have a lower footprint, requiring less water and land, and producing fewer greenhouse gases. However, getting enough protein, iron, and B12 can be challenging. Here we see examples of foods included in a plant-based diet. Notice the variety of fruits, vegetables, grains, and legumes which are essential to maintain a balanced plant-based diet. On the other hand, animal-based diets provide high levels of essential nutrients like protein, vitamin B12, and iron, which are more easily absorbed by the body. However, these diets have a higher environmental impact due to livestock farming, which contributes to methane emissions, deforestation, and water usage.
Like this is a normal speed.
Emphasize unprocessed foods, rich in nutrients, and free from additives. This approach is great for maintaining health, but requires significant time for meal preparation, which can get very busy. Processed foods are convenient and often more affordable. However, they frequently contain added sugars, unhealthy fats, and preservatives, which can lead to health issues if consumed long term. Organic foods.
So for a time sake, I skip a bit to then the conclusion.
Convenience, cost, cultural acceptance, and sustainability. By understanding these trade-offs, you can make informed decisions that align with your personal goals and values, supporting both your health and sustainable food system.
So this would be like the second example. And while it's downloading, I can, okay. It's how to ask your boss for a raise.
On how to ask your boss for a raise. Today, we will cover a comprehensive guide to help you prepare and strategize for this important career milestone. The first step in asking for a raise is to benchmark your salary. Research the average salary for your position within your industry and region. Websites like Glassdoor, Payscale, and Salary.com offer insights into salary ranges based on job title, location, and experience level. This will help you set a realistic and justifiable salary target. Here, you can see an individual researching salary benchmarks. This is a crucial step as it provides you with the data needed to justify your request for a raise. Next,
So now that was actually a perfect example. So because it downloads the images based on the alternative text, and not everyone put descriptive alternative text, so it could basically download not a really good result. So I can just basically see it was a slide 3, and I can go back to it and ask it, change the image in a slide 3. And going back to the rest of the video, so it would generate a, go ahead and try it again. So just going quickly.
Conclusion, asking for a raise requires careful preparation and a strategic approach. By benchmarking your salary, quantifying your achievements, choosing the right time, and preparing a solid case, you can approach the conversation with confidence. Remember to stay professional, be specific, and have a backup plan. Welcome to this presentation.
Okay. So loudness, while it is generating again, I will be going through line graph to show one of the examples. So Langsmith, sorry. So Langsmith is basically just a GUI representation for this stuff. So for example, here we have the example of, if I full screen it, so here we have the example of explain different traits of diet. So first of all, it will go ahead and then it's doing some Google search. And inside this Google search is, why is it not open? So inside the Google search is getting a bunch of results. Then is scraping one of those results specifically. And then a bit later on, we are doing another Google search for image, downloading one of the images. Then there's a bit more planning. Then there's another image search, downloading the image, a bit more planning. And then at the end is basically generating the text. And let's see if it's finished. So it's combining all of them. It should be finished soon. And it is generating the last one. It is compiling. Give it a few more seconds, and you would have your updated video with just the only thing changed being the third slide. So if I put basically a slide 1, and so a slide. So slide 1 is the same, but now the image, or is it still building? So I guess it's maybe called this one or this one. OK, but while this is building, maybe I can take some questions.
So these edges blocks, are they just GPT-4 LLMs just with different prompts?
So I am using LangGraph here. LangGraph basically is very versatile about how you can implement it. A node is basically just a function. That's it inside LangGraph. But in my implementation, yes, every node is a large language model with a specific system prompt and might have access to some specific tools as well. Not all of them has access to the tools. So in this image, the blue circles are the tools that the model has access to, and the orange rectangles are basically the agents.
Do you think it would be possible? Do you think it would be possible to integrate something like the Wolfram Alpha API as one of the tools? I'm just thinking about how bad large language models are at math. Maybe something like this would be a good way to address that.
OK, so I just, to reiterate, I'm not sure because this mic also picks that up. Your question was, could we basically take another large language models like Google's model for the math to make them better at them?
Integrate, thank you, say an API for some sort of online service or solving math problems in as one of the tools, if maybe that would be a way to kind of address how stochastic parrots aren't really known for their math abilities. This is really cool if that's maybe something.
Yep, so you could exactly do something like that because, again, you have the full power of programming here. So you could have like a planner or a supervisor there that basically decides whether this task is a math task or not. If it's a general, then send it somewhere else. If it's a math, then basically send it to a model that is primarily trained on math. And if it's just taking math in, math out, you could use another model to extract the math from the text, use this model to get that output of it, and then pass it to a third model to basically generate an output text out of it, like a human readable text. So you could basically go creative with this. You could add image generation with this. You could add, like, I have another project that is actually controlling robots. So it takes a picture every half a second, then uses that to basically decide whether it needs to accelerate, deaccelerate, turn right, left, or stop. So you could literally put anything at the end of your nodes as long as you can do it programmatically. Even if you cannot do it programmatically, you could put a human in the loop kind of concept, basically sends back the request to the user, and the user would basically approve, send a feedback or something, and then it goes ahead. Similar to how here we worked with the asking for a feedback for changing the images.
Thank you.
I was curious if
explain a little bit more what the supervisor does? As of, like, what are the specific tasks that you would require a model for, as opposed to just a list of functions?
Okay, so the question was basically, why do I need a supervisor in this architecture and what it exactly does? So first I wanted to, so I created this application just for this demo. It's not really one of my bigger projects that I work on personally. So here you could technically go without a supervisor because the main task is you need a researcher's team to do the research. You need a slide planner to do the slide planning, and then you need a presentation to do the presentation. But I kind of wanted to showcase the hierarchical team, and the hierarchical team, you have a person deciding where it needs to go. So I could do it programmatically, but I added an LLM. So just to make it more interesting, then I also added a session level memory. So now if you ask it a second question, then it doesn't need to research, so it just skips that part. So it directly goes into the middle team. And so that is now also created the video. So the first image is the same. Then the third image is changed. The rest is also the same.
When would those conditional edges be used? Would we get some sort of feedback mode where, let's say, for example, the writer gives feedback to the researcher?
So basically, those are done. I can actually show some of the code for the more technical people. So I have a router thing. A router is basically this. It uses a variable to basically go or not. And then the model is basically passing it whether it needs to go there. Let me just showcase. So here I just have some prompts. Basically, one of them here is just explaining if you need something, you could basically asking the other team. Let me see. This is a presenter. Presenter is alone. So researcher team. So here I have, so here it basically says you must ask the researcher team for assistance to get detailed information. And if we scroll down to basically where the conditional edge is, I have this function which basically takes the state variable, check the last message, and see if it was returned as a research or not. And if you see, here it says if about the topic replying by research, and then the topic you want more about. So basically, if the model message starts with the word research, then I know, OK, it wants to redirect it to the research agent. So I just extract that value here in this function and send it back to the researcher team. Otherwise, it can either decide to whether it wants to do a reflection state or send it back to the supervisor.
How does it know that it wants to, in this example, it wants more research, further research? Is it just part of the LLM and whether or not some research has been satisfied?
Yep. So basically, I'm forcing it a bit here as well that you must at least ask once. But so in one of my examples, which was I was asking a bit of one of my friends there. So it was very technical. So it was like asking about EPA's PFA study reporting. So for that, it actually had multiple rounds of Google search because the trained knowledge was much more limited, and it couldn't generate the amount of tokens that I'm asking it. So I'm also like forcing it to generate like a certain amount of tokens. So I have two versions. So you could do extended, which is basically generates 10 to 15 slides, or the short one, which would cost less, which is 7 to 9. So I'm forcing it to generate me an article with 700 to 1,000 words. If it doesn't have enough information to do that, it goes and search Google to get more information. Here are like some of the things that you can configure. You can basically configure if you want to use LangSmith. You can choose your model. You can decide whether you want to use basically OpenAI for the speech or use the Microsoft robotic one, which is free. And you can also customize your watermark. You can just delete it if you don't want watermark. And then whether you want extended. Extended costs a lot more, so like it triple the cost. So yeah.
So if you're asking you're trying to find out how to ask your boss for a raise, the first step is it fires your researcher, queries for information, and then depending on the actual length that it gets, it decides whether to do an
So yep, that's basically. So basically the question was, if you want to giving a topic, does it do first basically a research and then write an article? So if we just see what it does, so it first goes to the writer, then the writer sees, oh, I do not have enough information for this. So I just reply with research the topic you want to more about, which would be here. So it would be the research was trade-off of different diets. So that's basically what it does. Then that the other agent will do like the Google query, scrape some website so it has more information about it, and then return it back to the first agent. So now the first agent can actually generate an article.
And then it goes into the slide planner where all this information is divided into X number of slides.
So yep, let me show you here as well in an actual project. So for this example, if I go open the draft, so first we have the article. So this is what the first team generates. So it's an article here is like 57 lines, it's about 1,000 words. Then this is fed to the slide planner, which converts that to this. So this is an array of slides. Basically the type, whether it's a text or an image, the content in MD format, MD gets converted to HTML, HTML gets rendered, the rendered is an image. And then basically the notes that it wants to talk about. So basically what you see and what it is talking about are the different things. So it generates two stuff. And then you basically have your list of slides.
How does it know how the content of a single slide is actually coherent? It's by the length?
So that's where like I had a huge performance dip. So basically the question was, how does the model know if the generated context is coherent? So that's just the power of a large language model. Like if I use the same thing for GPT 3.5 Turbo, I was getting like 7 working results out of 10 tries and 4 or 5 of them being good. But after switching to GPT 4.09, 9 out of 10 results are perfect. So that's just the power of the model and how we can actually understand your system prompts and how we can remember them down the line. It just comes down to the power of large language model.
So the LLM does that logical split in this.
So yep, so basically the question was, the LLM does that logical split? The answer is yes, but I am doing a bit of hand-holding. So if I go to the agent, I'm basically telling it, so here, like I want to basically do, the article should be in a JSON format. You need to provide type, whether it's a text or image. The content, basically 3 to 4 lines of content in a markdown format. Use title and bullet points. If the text is type, if the type is text, or if it's on image, just the path of the image. And then basically I'm saying notes. So basically I'm trying to explain what I want to the model and crossing my fingers and hoping the model actually generating that.
That's cool. Thanks.
Have you tried to integrate like some agents to validate, like is there that validates that things working correctly? Like an LLM to validate LLM?
So the question was basically if I'm using any agents to basically validate the output. This is again just a demo project I made for here. I spent like 12 to 14 hours on this total, and it wasn't a really big thing. But I also work on agenting systems for production in my jobs. On those, yes, you are this is there are much bigger agenting systems than this. And in those stuff, yes, we have like validating and stuff like that. Like if I would want to add a LLM validator in this example, the biggest part that it is lacking is downloading the images primarily based on the alternative text. So GPT-4o also supports vision. So I could just download the image, send it to GPT-4o, and ask it to describe what you see on this image. And then basically use another large language model to basically say, does this description match of what you were searching for? If no, then I'm going to search another time. Or something like that. So this prototype does not have any. But if you're planning to sell a product like this or make a SaaS product, you should definitely add, because hallucination is the biggest issue working with large language models.
Is your code available anywhere?
Oh, yep. So my code is on my GitHub. So here is like just a, so if I just search my Cyrus 2281 GitHub, you should be able to get to my GitHub. So if you just scroll a bit down, it's in the pinned projects. So Mac Slider is Mac Slide Generator. And all you need is Docker and your API keys. That's it. You don't need to do anything else. I will also be putting this inside the, I guess, demo proposal in our AI Thinkers Discord channel. So if you're not there, make sure to join. You can find the link in the Loma invitation for this event.